about. I went to a lecture earlier today, well attended with several groups. Microsoft was represented as well, and there was a discussion around using tech, to solve some of these problems. What things can we do? And one of the areas that had been under discussion is to treat greenhouse gas emissions as a ledger, right? So every time you are looking at either reclaiming or producing emissions, to have a ledger balance, right? And treat the whole equation as a massive sort of budget. Look at the total amount of CO2 that can be emitted safely into the atmosphere before arriving at that 1.5 degrees Celsius mark. Treat that as a number, and then look to see how you can budget to not go past that, right? And looking for pluses and minuses in each category. Other technologies that sort of surround that is the use of blockchains to be able to um, appropriately record, entries in that ledger along supply chains, for example, because that's again where the whole infrastructure of putting that information out there and collecting this information and having sort of a unified approach to maintaining it is a challenge right now, right? Because it requires global participation to be on that sort of unified platform. It's not anything that the world has ever built together before, so it's going to take active participation from governments, the policy, manufacturers, companies, individuals, right, to be part of the of solving the problem. And technology can help. So thank you for coming today. Um, I'm going to switch over to something that we developed in a recent hackathon, sponsored by the UN and other tech sponsors. Um, and the result of that hackathon were a number of really interesting ideas that came out. There were over 4,000 participants across the globe, um, well over 200 groups that submitted ideas, and we were extremely lucky. We came in at the top of the ranks for the winning solution for Carby. This is what this idea and this presentation will be about. So the genesis of Carby was an idea, an entry into the hackathon, and on the heels of that effort, our plan now is to build this into a data-enabled platform for sustainability. So what is the motivation? Like, what is sort of the need here, and what sort of problems are we looking to solve with technology? Well, globally we consume more resources than ever, and we're soon to exceed the planet's capacity. Our economic and social progress over the last century has unfortunately been accompanied by environmental degradation that is endangering the very systems in which our future development depends. So to quantify this, the average U.S. household has an annual carbon footprint of 48 metric tons. So the goods and services that we consume make up a large portion of this number, the agri products as well. And many people would actually love to lower our footprint by making purchases from brands that advocate sustainability, but a remarkable only 26% of us actually do. So we want to lower our footprint, but we don't. And so what is this unmet need that we can come up with to help us close that gap? So this is the idea. This is Carby. Carby is a digital assistant to help people understand the carbon footprint of products that you want to purchase, either at home or on the go. With a quick snap of a photo, the app will find a product using advanced image recognition and will recommend lower carbon score alternatives to provide you with more choices that are aligned with your values, the power of consumers, the power of multiple voices combined to help influence and change the dynamic of the products that are consumed naturally. With the power of voices and the power of consumer dollars, you're going to see some products start to come up on top, right? And other suppliers who aren't investing in lower carbon infrastructure begin to be challenged economically, which is putting the pressure, I think, in the right places. So behind the scenes, the way this works is Carby looks to understand the products you want to purchase through image recognition. The mobile application has its own object recognition system to let you know they have a photo-ready composition in your view screen. It's done using MobileNet, which is a lightweight architecture that's deployed to mobile devices. But once you have that composed image in place, the user will take a snap of that photo, and that image is sent to our cloud services. This image is processed over multiple stages over a neural network orchestrated by a multi-layer decision tree, right, to finally arrive at which product this is. When that product is identified, we now know its category. We can look up other products in that category. We understand that product's carbon score. And if other products in that same category have a lower carbon score footprint, we're going to recommend them. So a robust data platform makes this possible, which is purpose-built on a modern data infrastructure. An emerging architecture platform and pattern that supports the development, testing, and operation of machine learning models for our next generation data products. So what are these? Like what are these sort of elements of a modern data platform, and why do we care about a modern data platform? Well, over 80% of machine learning projects fail. Now, there's a number of reasons why they fail, like we don't have the right data available, or we don't have the right skill sets available, or we're not asking the actual right question to seek and address a business value. But many simply fail because they didn't start by planning on the right data strategy and building an architecture to support it, a real-time sustainable architecture to get active feedback, an adaptive and scalable and extensible system that can enable operational agility. That's the integral part of a modern data strategy. And operational agility enables organizations to be more resilient when it comes to change management and data science, especially there's lots and lots of changes. To avoid vendor lock-in, our goal is to be as platform neutral as possible, built on open standards, using industry best practices. And it should be easy to integrate with other services that are built on those standards. That's the goal behind one of our platforms. So I actually like to talk a little bit about what platforming means in the context of data science and applications like Carby and others. So I don't know if folks are familiar with a blog. It's A16Z.com. It's from Anderson Horowitz. They're a venture capital firm, and they back many like bold ideas and entrepreneurs that are building our future through technology. And they're heavily invested in these sort of nascent, data sciencey products and companies, new-fledged companies. And they've asked these practitioners, like from these leading organizations, well, what do your technology stacks actually look like? And then what would they do if they were to rebuild that from scratch? And the result from those discussions is this reference architecture that I'm showing here. And there's a lot kind of going on here. Far more than you'd find in most production systems. It's a unified picture that covers almost all use cases, from analytics to machine learning, operation models, and everywhere in between. So I'm going to talk a bit about each column to kind of get a picture as to what these elements mean. Like in the sources column, it's where we're generating relevant business and operational data. And they come from a variety of different systems. In the next layer, we're talking about ingesting and transforming, which allows us to do ELT. So it's been flipped. It's no longer ETL, it's ELT. Extract the data first from these operational systems and then land that data in raw form into a staging area that aligns the schemas between the source and destination. Then we transform. We transform that data into a structure ready for analysis. And we do that step last because there might be ways in which we want to retransform for different levels of analysis. And having an architecture that supports that ability and services that allows us to do that is paramount to be able to go back to almost source to realign what you're looking at from an analytics perspective. Now, storage is where we keep our data in a format that is accessible to query languages and processing systems. And we try to optimize here between the sort of pull and tug between low cost and scalability and the requirements that we need for analytic workloads. So moving into the columns where we've got historical and predictive elements, we're either doing descriptive statistics or we're doing inferential statistics, right? And that's sort of the bottom line of what we're saying. We're doing things like business analytics or data science, machine learning, right? That's sort of the core of what those things mean. And providing this interface for analysts and data scientists to do the work is what we're doing here. In descriptive statistics, we're describing what happened, right? We're doing analytics and showing what happened. In inferential statistics, we're predicting what will happen. It's also where we build our data-driven ML applications for those types of use cases. And then finally, in the output column, we're presenting results of our data analysis to stakeholders using tools like Power BI or Tableau, or on the other side of this, we can embed machine learning models into operational systems and applications and custom built data products like Carby. And so from this unified architecture, we can emerge three common types of blueprints, and I'd encourage you to go into the link below is age16z.com there's a nice write-up of some of the things I'm talking about here. But there emerges three common blueprints. One is for business intelligence. So if you're looking to solve core and core to concept business intelligence type of solutions, you can focus on cloud native data warehouses and analytics use cases. That's the blueprint that you would probably go forward with. There's a second one for multimodal processing, which covers both analytic and operational use cases built around a data lake. And then there's a third, which focuses primarily on the operational use cases for building data-driven applications and products. It's a new and emerging blueprint, and it's an evolving space, but the elements for its core are there, and that's the ones that this is the blueprint that we're using for Carby specifically. So something like this. So this is an AI and ML type of blueprint for building data products. It is agnostic. It's designed to be sort of best of breed. You can envision taking some of these elements and seeing how they can line up to some existing services in any one of the platforms, right? But there's also a description of some of the tooling that you could use if you were going to go with your own best of breed solution, looking to build something together, using these services that will also live on the cloud. You can't get away from the cloud, but they'll be something that are more portable because they'll run on any cloud. All right. So in general, we're Carby AI is using this as a reference model, but with specialized differences that we need. But this new and emerging tech stack supports robust development, testing, and operationalizing machine learning models used by major tech companies that are building these data-enabled systems. And again, I mentioned it follows a best-of-breed approach. It requires more deeper skill sets, folks that are data engineers, machine learning engineers to build such a stack. The strength of this approach is that for organizations that want full control over their development process and they believe that machine learning and AI is a core long-term capability for that organization, then you want to in-house this. You want to sort of build this so that it's part of your IP. This blueprint is less appropriate for companies that are just sort of testing ML, or maybe they're using it for lower scale internal use cases, or maybe they're relying on a vendor for a full stack ML solution, and that's perfectly fine. Again, tech companies looking to build and make this core to their offering are looking for a blueprint like this. It's not easy, and it's one of the most challenging data problems that we have today is building something like this. And any questions so far? I can pause a little bit before I get into what we're going to do for Carby, because I know this presentation is more about Carby, but I wanted to give a little bit of talk about some of the architecture underpinnings and decisions that are being made and driven by apps like Carby.
Go ahead, Tim.
First of all, thank you so much. This is so spot on with what I have some questions about. One, cloud computing is still kind of expensive. So you want to try to reduce your load, as much as possible. As you're going through this whole design and build and testing process of implementing this kind of a project, how do you go about kind of conceptualizing, like, I should do this on a local machine and this seems like it's going to be light enough that we can put that part in the cloud? Like how do you just kind of start that question for a function?
I think primarily we're almost cloud first, regardless.
Okay.
And what we might be looking to do is, if it's Amazon, we're doing EC2, or we're just creating virtual Docker containers to deploy them somewhere. And we might, and so I'm a believer in infrastructure as code, so that you can take this and spin them up and then tear them back down as life necessitates, and then scale them out when you need to as well. So I think to control costs, at least initially, you're not really building this as robustly at first. You're building it to support what you need for operation. Well, first, not necessarily operationalizing machine learning, but more on the analysis part of it, to do your initial investigation into EDA and finding out what's going to work, all of the modeling and tuning that goes after that. Then you kind of go back. Okay, great. Now we've got some models. Let's go back and build some of the additional plumbing that we need to support this more programmatically or autonomously, right? So introducing things like data flow automation, like with Airflow or something like that. You don't need to do that right off the gate, right? You can get by with doing a lot of this with shuttling some data, doing your analysis on that data, through notebooks, other exploration activities, creating some models, but then having a little bit of rigor. It's like doing the POC or the spike first, which is not production code. I can do a spike. It's sort of throwaway, right? But keeping that knowledge around so that when you're going to rebuild it, right, for a production level type system, and that's not saying this is all the way to production until you serve models, appropriately from an ML store. But following a pattern like this helps us at least have visibility into what we need to do in the future.
Excellent. One other question that I had for you, like I find myself, making, I come into it with like having a couple assumptions, and so like I know what I want to get, and I'll start making some data models around that, and then as I start kind of aggregating that, I find that I'm wasting a lot of time making models that are so narrow. Like, how do you go about making a model that you can go back and alter or build in? I know it's like a really vague
Yeah,
question.
yeah. That's the art part in the data science equation, right? And it is exploration. It is analyzing features. It is sort of using some techniques to, look at ways in which certain features provide, um, more power, right, to your model, and
Yeah.
knowing which ones um, contribute, which is ones that aren't providing much of anything. You throw them away, and also looking for ways in which you can re-engineer certain features that might be more appropriate depending on the machine learning models that you're applying. You want to do things where you're scaling your attributes appropriately. You're looking at ways potentially of binning information as opposed to using it as straight up numerical values, right? There might be some advantage to doing that. It really all depends on the domain you're investigating to
Okay.
know what to, yeah. So it's a little bit art, a little bit domain knowledge, a little bit sort of science on the data science side of it, and then just the willingness to sort of explore and keep trying, right? You might find that you're not getting any predictive value in your models with the data that you have. So then you have to say, I don't have the right data for what you want me to do, and you have to go back and get that data somehow.
Gotcha.
And that's informative information for the stakeholder to know. We don't have value. We have power value in what we have. We could do something else with it, but it's not what you wanted. You want to
Yeah.
pivot or try something with where we're going to get the data that we need. ML
Thank you
is a
so
lot.
much.
Yeah, no, ML is a lot of exploration, right? To know where you're going to find the strength in your features. Now, if you're using deep learning, there are techniques where you don't have to worry about that as much, because if you have enough epochs in training, the model itself will self-tune the weights according to what it knows and based on the outcome that you're tuning towards. And with enough, speaking of utilizing energy, with enough energy, you can then sort of coerce the model that you want out of it, agnostic, of any sort of cleanup of which attributes you think are going to be stronger in favor. So that's a deep learning approach where you can when you have the the luxury and time and resources to do that. And even then, you still likely want to do some tuning around where you think you're going to have some strength. So hopefully that makes sense. I'll thank you for the question. That's an awesome question, Tim. Anyone else for questions before I move on? Cool. All right, so I'll go into a little bit of Carby again and discuss what we're doing for our approach. So we're relying on a couple of core and critical sort of 6 pillars that we're resting Carby on top of, and that is we're relying on the value of strategic partnerships with research scientists and manufacturing and supply chain specialists, product domain experts, and companies who are aligned with an ESG agenda. We also have a product database which ingests data from private and public sources, and an open API for producer partners who wish to submit their information directly. And then we have a multi-stage neural network which finds products based on consumer captured images. And the interesting element of this is that the consumer captured images actually become additional material for us to reinforce our model's learning. And then we have the carbon score, which is based on published standards from the research community and other efforts that exist through other global efforts to actually come up with creative ways to address and come up with computations around carbon scoring across the supply chain. And our goal is to provide alternative products with lower carbon scores based on these types of calculations. And then I mentioned we have that modern data stack, which requires that we make the right choices. We're moving, if you have a software background, we're moving more from software based purely on code to systems that combine code and data to deliver value. And effective data capabilities from platforms like this are becoming table stakes for companies across all sectors. And winning at this can be a durable competitive advantage. And last, our application will pack all these features that we want into our data product into an easy to use, human relatable experience, which we think is also very important. So I'd like to showcase a little bit of the demo. And to do this, I'm going to have to switch my screen share to my phone. And I'm not sure if this will require me that I unshare the one, but we shall see. Let me know if you see my phone.
Yes.
Yeah, we see it, Kevin.
Okay. All right. Oh yeah. There we are. All right. So here's Carby. Here's our Carby prototype. And right now we're sort of looking around with bounding boxes. And at this level, this is pre-tuned for just basic object detection. And right now it's just thinking it's a TV. So I'm going to actually take a picture of this. It thinks this is a box, so that's fine. All right, and it found our product. These are French products. France has a little bit of a heads up into producing actual carbon footprint scores with their products. So we relied on that for our demo, for our prototype. So this product has a higher carbon score. So we have the ability to click on that score to see if there are some other products that would be available that we might consider purchasing instead. So let's go back and check out another product. Let's see. Let's do the chocolate. Okay. Chocolate found. Yes, brilliant. 2 other products, chocolate, that have a lower carbon footprint than the one that we selected. So if you're at a store and you're looking to do this, and then seeing that you have the option of choosing from different products, or if you're online and doing this is kind of the equivalent of being online, because I'm taking pictures of pictures that were found independent. So the models were not trained on these pictures. So here's a more complex one. We did not train on this, but it's got sort of a, yep. So we've got this other product, this 1131. And surely we've got some other products that we can choose from, different teas that have a lower carbon footprint. You wouldn't think that tea has such a high carbon impact, but there are some products that do. So now I'm going to share back. Any questions about the demo? We were pretty excited to work on this. We did it in 3 days, so it was really aggressive. We divided, sort of a division of labor. I worked on the mobile application, and as some folks might already know, I never really developed a mobile application in this sense before. So it was a quick deep dive into learning Flutter on the fly, and then coming up with some sort of actionable front end. So that was a lot of fun. We were having a lot of fun during that journey of building this out. Let me see if I can share my screen again.
Kevin, this is Pat. I have a question for you on the data that the app draws from in terms of product comparisons.
Sure.
What I know that that data is drawn from or extracted from the cloud, correct?
The data sets. So the raw data behind training these models, the products come from available data sets that were many of them were made available to us in the hackathon during that experience. So, and I should probably explain, leading up to the hackathon, we had a few sessions on ideation, figuring out what sort of application that we wanted to build. In fact, this idea started from an earlier conversation around getting nutritional value on products and understanding sort of the macronutrient value for each one of the products that an individual might want to purchase to understand whether or not this is a healthy choice for them. But the same sort of approach, like taking a picture of the product, having that product come back, showing its nutritional value score, and then recommending other products with a higher nutritional value. On the day of the hackathon, so that was an idea, right? On the day of the hackathon, we saw that there was a data set available for us with carbon scores, right? So that naturally, that was a perfect pivot to say, well, we've got this idea already on having an application that could do this with nutritional scores. This seems like a nice sort of pivot towards a carbon type of scoring approach.
Got it.
And that was sort of the pivot on the day of the hackathon's challenge release. So a number of challenges were put out to the community. They hinted at some of the challenges, but they didn't give them until that day. And the idea there was sort of a build up into coming up with some ideation before the day of the event.
Got it. So do you anticipate your data, obviously it needs to be dynamic and evolving. Are those data sets going to change or morph?
Yes. Oh, yes. You can imagine that.
Right.
Data will change. New products will be
right.
invented and put to into the world daily. Right. So that's sort of going back to the emphasis on the architecture, right? To have something that is resilient, that can support such an arrangement, right? Because we're envisioning multiple types of products with multiple categories, and being able to retrain a monolith, right? That's the typical sort of approach,
Right,
isn't going to work because we'll be retraining, retuning daily. Instead,
right.
you're looking down to a lower level model that has the knowledge within a category of products. And when the new product comes out, you're not retraining everything. You're training just the elements where that product fits in.
Got it. All right. Thanks, Kevin. I know there are several other, Brian can manage these questions.
Yeah, Kevin, when you're doing, I guess, training the model on like the photographs of the product, are you actually taking photographs of all these products, or you already have like an image of what it looks like and training the model to determine if
So we have a variety of images available on that product from product databases. Images are provided. Now, to your point, you need a little bit of image diversity when you're training so that you can generalize a little more. And there are tools in which you can use to alter images ever so slightly in different ways so that it gives the models a chance to be more resilient when they see the product, say, sideways, right?
right.
Or tilted in some way or different.
Great, thanks. I think Tim, you had your hand up.
Yeah, Kevin, great stuff. Was there a concern, and if there was, what was the mitigation over if I have a product and I'm worried you're making claims about the carbon footprint that's not accurate, either because you didn't have exactly the right product or I didn't agree with that, and now it's negatively perceiving my product
Yes.
through your app, and they come down with vengeance on it.
Yes.
So.
Brilliant question. Yeah, that is a concern. So to alleviate that concern and to address it, that is the reason why we seek out the knowledge of environmental scientists, right, and using well-documented approaches to calculate these scores that are universally applied, right? So it requires a little bit of participation and adoption and having authorities, right, that can say that this is the generally accepted approach, and we seek to use those approaches so they can't be disputed, right? And really, there are so many techniques to arrive at the carbon score calculation, and that is an area where there has to be some level of consolidation, right? And the best way to sort of consolidate that information is to have companies self-report that, right? So if it's in dispute, then work with a way where you can get that, follow these systems, these protocols, subscribe to the blockchain, for example, like and submit your product's manifest along the supply chain so that we can inspect that information and provide it. You can provide it yourself as long as it's not disputed. And one way to look at that is if you have a blockchain, that is a ledger which is fully transparent. Everyone can see how information got entered, right? And it's a good way of having sort of the checks and balances in such a system. Did that answer your question?
It did. It probably was a little more straightforward on the nutritional side, right? Because that really is much more rigor around the reporting of that versus, the carbon footprint can still be a little squishy in terms of the quantification of it. Oh, thank you, though. That was a good answer.
Tim Grogan, you had a question?
Yeah, so what are some good tools or resources to use as you're going through an ML development project to just stay cognizant of security needs, and that, how do you avoid, basically the easiest way to say it is, how do you avoid building security risks?
How do you avoid building security risks?
Yeah, it's because one of the first pushbacks that I always get is, well, how are we going to protect that? Or a lot of discomfort with, gathering information from an environment in such a thorough way. I just always see a lot of pushback to that. Mostly,
I think you're opening up a big sort of question around. Is it more along the lines of data privacy, or just ensuring that
like
the
let's say,
doctored along the way?
so you're gonna, in order for this to work like in an IT environment, you're gonna build some kind of collection tool that's gonna take that data and put it somewhere else. And it's just, I know that one of the things that I struggle to give a good answer for is how do you navigate managing that and ensuring that you're doing what you could be doing effectively to ensure that you're not implementing security risks. Like encrypting your data as a flat file, for example, so that anything going up to the cloud with, that would be a simple example.
Yeah.
If there's any tools or
yeah, I would
recommend.
Yep. I would suggest looking at the sourcing sort of tools that are available, that will address some of those concerns, like taking a look at like Singer or Stitch or Fivetran. Those are some products that will help to do the ingestion piece where you're looking to extract and pull into and land in a staging environment. And once you're there behind the zone, I think you have less concerns. But looking at how that information is first collected using products like that, there are documented means in which they are initially configured and set up that might alleviate some of the concerns that you're looking at.
Awesome. Thank you so much.
Mm-hmm.
All right, that's all the questions at the moment, Kevin.
Okay. So I will just continue a little bit describing a little more about Carby and what we're doing. If you're curious about our approach and what we're seeking to do, went backwards. So we do have a goal for an MVP that is for our first pass solution. Our target is to have limited products at first and second stage classifiers, a basic carbon score, and our goal is to have an early MVP beyond just our prototype. And the reason the momentum towards an MVP and putting this out to be more fully capable is we have actually a target. The past, like what we've already completed we're calling it a 3-day design sprint at this point. Our next goal is to continue to gather our partners, build our MVP, and our target is actually the Global Climate Change Conference in Glasgow this November. It's COP26. We've been speaking with a number of folks who are interested and think that this is a viable candidate for being brought to that audience. So our goal is to move that towards that goal. From that point, if successful, we anticipate that we'll need to do additional funding to scale the solution for a pilot geography. And then after applying our lessons learned from the pilot, we're setting our target to include more geographies, and finally, a global rollout. So again, these are just sketched out plans, but this is something that we're looking at evolving. Carby has plans to be an entity. If you're kind of curious about the makeup of teams that could be assembled to build such a product, we see sort of some of the similar roles you might expect to see in normal software development teams. Those elements still exist, but beyond the product owner and scrum master and tech lead, we've got specific roles along a data engineer, ML engineer, and data scientist. And then after those roles, we begin to see the more traditional mobile developer, UI or UX researcher, and UI UX designer, some testers. Specific to us are along the lines of having a marketing strategist and environmental scientists on our team. So I'd like to kind of close here with just same words as which we started. 60% of purchase behavior in the U.S. is influenced by a company's social responsibility reputation, and that awareness is not going away and will continue to influence our decisions and brand choices moving forward. And we believe that Carby fills a gap on an unmet need by allowing and providing a heightening awareness of the carbon footprint for each and every product that consumers wish to purchase, and offer consumers choices to select from brands that are more consistent with their values. So please follow us on Twitter and LinkedIn. We're at Carby AI. Please also find me on LinkedIn if you'd wish to connect. Look forward to doing that and continuing our journey, and welcome you to follow along.
Kevin, thank you so much. I don't know whether there are additional questions. Maybe we can give it a few and see if any are posed. Otherwise, this will have been one of the more efficient ITKAN meetings in recent history, which is fine. I see Tim and one other question. So, Brian, I'll give you a break. Tim Rosler and then Tim Grogan. Go ahead, Tim Rosler.
I appreciate, to me, I'm so curious. I can ask questions all night long, so I appreciate a little bit of time. But, also to kind of pull it into our group and something that's sensitive. Any thoughts about accessibility?
Tim, you're breaking up.
Other ways to, have you thought of?
Kevin, I don't know.
Let me try that again. Any better?
Tim Rosler, I think broke up.
Is it any better? Is that any better to hear me?
Oh, yes.
Yes.
Kind of pulling it into the theme of the group, any thoughts about extending the accessibility of the app? It's a very visual-based app, which might be limited to some of the users that could use it. Has there been thoughts about other ways to extend it to identify a product through other ways, or other ways to increase accessibility?
Yeah, that's a wonderful question. So I mentioned the aspect of the user experience, and that is certainly a treatment that we want to entertain. But we're sort of intentional in calling this a platform, and that's because it doesn't necessarily have to have a mobile application at the front end of it to be a platform, right? A platform can be I have a need to identify, elements, products, and understand their carbon footprint. This can be integrated to provide that information seamlessly if you know the product more directly, right? So if we treat this as a repository of information, you can consider other use cases and how you can transact or interact with other services by being a supplier, both a receiver, collector, and supplier of this information. So I appreciate the comment, and I think that there are ways in which we can entertain having more accessible access to this information. I would also admit that we're not there during in discovery of what that means quite yet. We're very early on and figuring out all the available use cases that we could entertain. So naturally, with any new fledgling company, there will be some pivots along the way, and we might see some additional pivots beyond the current user interface that we have today.
Great, thank you. And it's a great point that you made, that really, as you build as a platform, the different front ends and processes, can be ubiquitous to use the same platform. So kind of building it with mind as you extend accessibility, you have the platform that can support that. So great. No, thank you for those thoughts.
Tim Grogan, I think you had a question as well.
Yeah. Any tips for how to go about finding public data sets? Like, I've started off trying to use like Selenium and the Google API to just use Python, but all the time I find that the script works, but it's getting flagged or stopped because of authentication issues. usage rights issues, and anywhere that you would point me to take a peek at for that, you know, finding public sources of information when you have a specific data need.
Yeah, I think Google does have, if you do a little bit of searching, they have like a special zone for data sets, that ones that are publicly available, and many data sets you'll find are accessible through data.gov. So there's much information that's been assembled, um, through, by U.S. government agencies, and it's been made available. We're very lucky in this country to have access to that information. I think, it's not as pervasive everywhere, and we have that advantage. So if you're looking to explore and look at analyzing data in different ways, I would suggest going there. There's such a variety. I mean, there's between census, information, cause of diseases, economic situations. It's all publicly available from data.gov, and there's a huge repository.
Excellent. And I just want to say thank you again so much for taking the time to do this for us today. And Pat and Brian and everybody, thank you guys so much for making this something that that we can take part of. It's an incredible opportunity, and I'm really grateful for it.
Thank you, and for coming, and Pat, thank you for putting this together. And I've been
Kevin, you're overstating it with regards to me, because I lean heavily on Brian.
Of course, yes.
So thank you, Brian, as always. And Tim, you're very welcome. Kevin, and our speakers at ITKAN have always been stellar. Kevin is in a long line of stellar and subject matter experts, and with who are engaged in intriguing work. And as per usual, most of it goes well over my balding pate, but I take away something from each presentation. So thank you, Kevin. Fortunately, there are deeper minds on most of our calls, including this one. Steve says, enjoyed it a lot, just started me thinking. So
Good. We like that.
It's about time Steve started thinking. So all right, before Steve retorts, Kevin, thanks so much. Yeah, he said. Brian, again, thank you. Anyone else have comments or compliments for Kevin? All right, hearing none, we're adjourned. Thanks again, Kevin, and everyone for joining us. Have a safe rest of the week and weekend. Stay cool, everyone.
Stay cool. Be like Fonzie.
Awesome stuff. Thank you.
All right.
Thanks, guys.
Thanks,
Kevin. Steve said, thank you all so much and stay well.